Generative adversarial network (GAN) is formulated as a two-player game between a generator G and a discriminator D, where D is asked to differentiate whether an image comes from real data or is produced by G. Under such a formulation, D plays as the rule maker and hence tends to dominate the computation. Thus, we propose a GAN training method named GLeaD, aiming at improving the fairness of the game between G and D. Specifically, D is additionally assigned a generator leading task. We require D to extract features of the input images for G to reconstruct them. The experimental results validate the improvement of the synthesis quality. Next, I will make an introduction of our paper in detail. In the training of vanilla GANs, D plays as the rule maker and hence tends to dominate the computation between G and D. Thus, the optimal solution, where G can recover the real data distribution and D can hardly tell the source of the images, cannot be achieved. To address this issue, we propose to assign D a task led by G and backpropagate the gradient from G to D. In the training of GLeaD, during discriminating, D is additionally required to extract representative features so that G could reconstruct the input images with these features. And these features, including spatial features F and global latent codes W. These features are sent to the fixed G, the generator, to reconstruct the input images. The perceptual loss is adopted to penalize the difference between the reconstruction and the inputs. As a result, the viewpoint of D is forced to be aligned with G, and the fairness of the game is improved. Also, D's ability to extract representations is enhanced. Here are some quantitative and qualitative results. To validate the improvement of the fairness during the game between G and D, we visualize the realness score predicted by D. The reduced gap of the realness score suggests that, under our setting, D is forced to learn to discriminate from the perspective of G. Thus, the task of discrimination becomes harder. We also visualize the reconstruction results. Recall that we first adopt D to extract features of the input images during discrimination, and then we send these features to G to reconstruct the inputs. The reconstruction performance validates that D could extract strong enough representation, meeting the requirements of G, and that the view of D is successfully aligned with G. In the experiment of attention visualization, we send some synthesized images with artifacts to D for discrimination, and GLeaD is adopted to visualize the attention of D. The improved D could better detect the visual artifacts, which can in turn improve the synthesis quality. In summary, this paper proposes a GAN training paradigm named GLeaD, aiming at improving the fairness of the game between G and D. The generator leading task is designed as a reconstruction task. D is required to extract features of the input images for G. The experimental results validate the improvement of the synthesis quality, fairness, and the representation of D. Thank you for listening.